Here we go. 9 o'clock. Oh, I'm sure you don't want to look at my ugly face. I don't even want to look at it. See that one. Okay. Wish I could see. I can remember. Well, I guess. Okay, we talked about this one a little bit last time, and that's solving systems of equations by substitution. Oddly enough, we're going to substitute one value in for the other. Remember, when we have two variables, an x and a y, a and a b, whatever, and you cannot solve anything unless you record. Yes, I did. Well, you know that. Okay, so what we're going to do is we're going to take this equation, and it doesn't make any difference which one you do. Solve the equation for one variable or the other. This one's already done for us. Y equals 2x. So in the other equation, we're going to substitute 2x for y because y and 2x are the same. So we have this. We have 3x plus 5 times y. Y is 2x equals 26. Now we have one variable, and we can deal with that. So we do order operation. So we have 3x plus 5 times 2x is 10x equals 26. Combine like terms. We have 13x equals 26. Is everybody with me here okay? Okay, divide by 13. X is 2. That's just x. We have to know what y is also, because remember, this is a point on a graph where the two lines intersect, where the two lines cross. It would look if you had this and you had this. This intersection right here is the solution to these two those two lines. Now what we do is we know that x is 2. Get back into either equation. It doesn't make any difference which one. Let's use this one because it's already solved for us. Y equals 2x. So y will equal 2 times 2. X is 2. So y is 4. So our intersection is, remember, it's always in the form xy. 2, 4. That's our answer. That's our solution. Okay. Now, these things get a little bit more complicated, but really not very much. This one, x plus 3y equals negative 28, and y plus 5x equals 0. Now, we can solve either one of these system of equations. We can solve either one of these. We can solve this one for x pretty easily. We can solve this equation down here for y very easily. Since these numbers are bigger up here, let's use this one because I'm lazy. We're going to take 5x over to the other side. So we subtract 5x from each side. We have y equals negative 5x plus 0. Plus 0 doesn't mean anything, so we're just going to leave that off of there. Now we plug this into the other equation. You can't plug it back into this one, else you're not going to get anything. It's kind of like kissing your sister, you know. It's not, no. We have this. We have x plus 3y, but instead of y, we're going to plug in negative 5x equals negative 28. Now we order of operation. We have x. Now 3 times negative 5x is negative 15x equals negative 28. Okay, I had to multiply 3 times that. Now we're going to add, excuse me, we're going to combine like terms. So we get negative 14x. Okay, this is 1 minus 15 is 14 equals negative 28. Divided by negative 14. X equals negative divided by negative is a positive. If you're not sure, your brain goes numb or whatever, put it in your calculator, but please don't tell Professor Burke on me. Negative divided by negative is a positive. So x is 2. Now we have to find out what y is. Excuse me. Look, this one's already solved for y. So let's plug it in here. Y equals negative 5x. Okay, y is negative 5x. Now we plug in 2 in for x. So y equals negative 5 times 2. So y is negative 10. Negative times a positive is a negative. So our answer here is 2 comma negative. That's our solution. It's about as difficult as these get. There's some that are a little bit more involved, but really not very much. No, I'm stupid. Okay, we're going to kind of shift gears here a little bit. There's 3 ways of solving these systems of equations. Graphing's probably the easiest. Substitution's probably the next. The next one actually is easier, but it's harder to understand. It's really pretty easy. Solve by elimination. What we're going to do here is we're going to have two equations. X plus y equals 5 and x minus y equals 3. System of equations. What we're going to do here is we're going to add the 2 equations together. Okay, add them together. This one plus this one. And when we do, we're going to eliminate one of the variables. Okay, we're going to add the 2 equations together. When we do, we're going to eliminate one of the variables. Look, let me back up here a minute. If we have 2/3 and we multiply that by 5 over 5, 5 over 5 is 1, right? But when you multiply anything times 1, it's not going to change the value of it. It's just going to change the look, which is 10 over 15. This and this are the same. They're equal. They just look different. And that's what we're going to do with some of these. Now, this one we don't have to. Because look, y minus y is, remember, we're going to add these 2 together, these 2 equations together. And when we do, it's going to eliminate or get rid of one of the variables. Am I going too fast? Everybody with me? Okay, so we're going to add these together. X plus x is, let's see, the 7, 30 days, that's September, 2x. Y minus y is 0. Anything minus itself, 0. Equals 8. Okay, now we have one variable here. Divide by 2. So x is 4. We plug this back into either one of the equations. It doesn't make any difference. Choose the top one. X plus y equals 5. Use the bottom one if you want. It doesn't make any difference. It's going to end up with some godless negative number. So instead of x, we're going to plug in 4 plus y equals 5. Now we have a real simple algebra problem. Subtract 4 from each side. Y is 1. Remember, that's y, not x. Now let's plug this back into let's plug it back into x plus y equals 5. Now, y we know is 1. So we have x plus 1 equals 5. Subtract 1 from each side. X is 4. So our solution here is 4, 1. Okay, I told you this up here because we're going to end up multiplying something. Let's see, what else do we have going on here? Now, basically the same stupid problem, but let's do it anyway. X minus y equals negative 2, and x plus y equals 10. Okay, now you can see that y is going to be eliminated. We don't have to do anything here. This one. And any number minus itself is 0. So we get 2x. Okay, x, remember, we're adding these two equations together. Equals 8. Divided by 2. X is 4. Now we plug this back into, let's use the bottom one. X plus y equals 10. Doesn't make any difference. You can use either one. X is 4. Plus y equals 10. Subtract 4 from each side. Y is 6. So our solution here is 4, 6. Okay. What could be more fun? Anybody's got a big turkey dinner planned? Mr. Razzo and I don't have anywhere to go. So Mr. Razzo says that he was going to bring me over a peanut butter and jelly. Mr. Razzo, I want those on toast too, by the way.
Crunchy or smooth?
A crunchy, yeah. Crunchy peanut butter. And strawberry jelly. And don't diss me here, or you're not going to pass this course.
Dear.
Mm-hmm. Okay. What in the world is this? No, I don't like that. Well, let's see. Y equals negative 3x. And negative 3x minus y equals 3. System of equations. We want all the variables on one side of the equation. So we're going to have to add 3x to each side. So if we have 2y equals negative 3x Okay, we want to move the 3x over to the other side, so we're going to add 3x to each side. We get 3x plus 2y equals 0, because we move this over here, that's going to leave 0 over here. Now we have negative 3, the other equation, negative 3x minus y equals 3. Now we're going to add these two equations together. 3x minus 3x is 0. It's gone, it's eliminated. 2y minus y, 2 minus 1 is 1, so y equals 3. Okay, right. Now what are we going to do? Well, let's put it up here in this original. So 2y equals negative 3x. But again, it doesn't really make any difference. Y is 3, so we have 2 times 3 equals negative 3x. This is 6 equals negative 3x. We're going to divide by negative 3. And then x equals positive divided by a negative is a negative. Is a negative 2. Okay. Now let's plug it back in. Let's see. Why don't we plug it into this top one again? 2y equals negative 3x. There's a y here. X is negative 2. So 2y equals negative 3 times negative 2. Bear with me. Am I going too fast? Please tell me if I am. So 2y equals negative 3 times negative 2 is a positive 6. Negative times a negative is a positive. Divide by 2, y is 3. So our solution here is negative 2, comma, 3. xy. Okay. Okay, let's see, what do we have here? Okay, this is about as difficult as these get, and it's really not very hard. This is why I was showing you that fraction. Whenever you multiply something times 1 or by anything else, it's the same value, it just looks different. Okay. You look, if we added these together, we get 5x. If we added these together, we would get 1y. So what we're going to have to do is we're going to have to multiply top or the bottom by something that will give us the opposite of the easiest thing to do here, because 2 is not a factor of 3. We'll talk about factors more next week. 1 is a factor of 2. So what can we do? What do we want this to equal? We want this to equal negative 2y, because when we add them together, negative 2y plus 2y would be 0. Is everybody with me here? This is kind of confusing. I've always thought. I remember I had a girl one time, real pretty. I think she liked me, or she was always, boy, you're just stupid. She said, boy, you're going to have to explain that again. That doesn't make any sense at all. Well, and she's real smart too. Reminded me of myself. So we're going to have to multiply one equation or the other. Sometimes you have to do both equations. I'll probably not do that to you anytime soon. What can we do to negative y to get it to a positive 2y? I'm sorry, to a negative 2y. We're going to multiply this whole equation times 2. Then we get 4x. 2 times 2x is 4x minus 2y. You see, now that's what we want here. Because when we add them together, we want it to eliminate this variable. Equals, was it 24? Something like that. Okay. Okay, now remember, this equation here and this equation are the same. They just look different. Because we multiplied everything in here by 2. Doesn't change the value of this any. It just changes the look of it. So now we add these two together. Remember, this equation and this are the same. So 3x and 4x is 7x. 2y minus 2y is 0. That's what we want. Equals 21. 24 minus 3 is 21. Divide by 7. X is 3. Now we plug this into either equation. Choose the top one. 2x minus y equals 12. You can use this other one down here if you want to, but the numbers are nastier. Okay, so now we have 2 times x. X is 3. Minus y equals 12. We do order of operation. 6 minus y equals 12. Subtract 6 from each side. Negative y equals 6. We don't want to know what negative y is. We want to know what positive y is. What we're going to do is we're either going to multiply or divide, doesn't make any difference here, by negative 1. Divide by negative 1. So then y is negative 6. So then our solution is 3 comma negative 6. Let's see. Okay. So you get this one up here, so it's smart. X plus y equals 3. Excuse me. Negative 3x plus 2y equals negative 19. You see, we could multiply the top one by 3, then we'd get 3x minus 3x, and that would eliminate that one. Or we can multiply the top one by negative 2, then we get negative 2y plus 2y. Let's do that one. Because these numbers, well, no, we could do, let's do the top one. Do the top one by 3. What would we get here? We get 3x plus 3y equals 9. There's a y here. Remember, this equation and this are the same. They're equal. They look different. Now we're going to add these two together. Negative 3x plus 3x is 0. And we have 2y and 3y are 5y equals Negative 10. Negative 19 plus 9 is negative 10. Divided by 5, y is negative 2. Right. And take a drink of your Diet Coke. Let's use this top equation because it's a little easier, it looks like. Again, it does not make any difference. But instead of y, we're going to plug in negative 2 equals 3. Excuse me. We add 2 to each side. Too stupid. X is 5. So our solution here is 5 comma negative 2. Always in parentheses. Point is always in parentheses. Kind of like that. You can see that these problems here are actually much easier to do than the substitution misery. Here's one of the substitution problems. You see how long that thing is. It's easier to do, except for the length of it. This one takes a little more understanding of what's going on. Okay. Okay. What if you have this? Get this if you're so smart. 2x minus 8y equals 3. And we have 4x plus 5y also equals 0. Remember, we want to eliminate one of these variables. Now, 5 and 8 are not factors, or 5 is not a factor of 8. So we can't do that one very easily. We'd have to do both of them. But 2 is a factor of 4. So now what we want to do is we want to change this 2x into negative 4x. Am I right or am I right? Right. I'm always right. Well, sometimes. We're going to multiply this one by, excuse me, negative 2. Multiply everything by negative 2, and we get negative 4x plus 16y equals 0. Right? Right. And remember, the equation and that equation are the same. As we multiply everything by negative 2 here, it doesn't change the value in it, it just changes the look. We're going to add these two together. 4x minus 4x is 0. Is it 21? 21y equals 0. Divide by 21. Y is 0. If you forget what this is, put it in your calculator from top to bottom. 0, fraction bar means divided by. 0 divided by 21 is 0 divided by 21 is, make sure you put it in right, 0. Okay, now if you did it the other way, the 0 was on the top. 0 divided by, stupid boy. I mean, if it's on the bottom. 21 divided by 0. It's going to give you a math error. What it's saying is, stupid boy. What that means is, kind of back up a little bit. If we have 0 divided by 21, what this is saying is, how many 21s are there in 0? No, there are none. There are no, so this would equal 0. However, if you said 21 divided by 0 is 0. What this is saying is how many zeros are there, or how many nothings are there in 21? Well, it doesn't make any sense. You can't say this is undefined. This says how many zeros or how many nothings are there in 21? Well, it doesn't make any sense. Okay, so here we have y is 0. We plug it back into either equation. Let's do the top one. That's a little easier, I think. X minus y equals 0. So plug in 0 for y. 2x minus 8 times 0. Okay, negative 8 times 0 is 0. So we have 2x equals 0. Divide by 2. X is 0. We have this. Is this a possible solution? Yeah. 0, 0. What that means is the two lines intersect. One will go here. The other one will go here. They intersect right there at 0. That's what that means. Okay. This next one, this is about as hard as these problems get. And to tell you the truth, I don't remember whether you're going to get one of these on the final exam or not. I'll usually get a copy of the final exam first. The answers will be available for $10. No, just kidding. Now, don't go running to Professor Berkey. That boy's going to sell us the answers. No. What I'm saying is, I'll get a copy of the final exam before, excuse me, before you take it. I'll go over the final exam with you. Now, just like your test, I'm going to change the values, but I'm not going to give you the answers, probably. Okay, so what if we have this? 2x plus 3y equals 21. 21, stupid. And 5x minus 2y equals negative 14. What are we going to do here? 2 is not a factor of 5, and negative 2 is not a factor of 3. So what are we going to do here? We're going to have to change both of the equations. And like I said, this is about as difficult as these get. Let's try to eliminate the y here. Numbers are smaller. It doesn't make any difference. So we'll multiply this one by 2, this one by 3. 2 times 3 is 6, and 3 times negative 2 is negative 6. So there we can eliminate those. So we get 4x plus 6y equals 42. Is that right? 4x, 6y. Yeah. We multiply the bottom one by 3. We get 15x minus 6y, and that's what we want. We want these numbers here to be opposites of each other. Equals, what is it? Is that 42 also? I think so. Negative 42. Okay, and remember, this is the same as this. This is the same as, well, that. You can see this is what we want here. We want one of these pairs of numbers to be opposites. And that's what we got here. 4x and 15x is 19x. 6y minus 6y is 0 equals 0. Wait. We divide by 19, and x is 0. We're going to plug this 0 into, let's take the top one. And again, it doesn't make any difference. We have 2x plus 3y equals 21. All right, my brain just went numb. I think so. So we have 2 times, excuse me, times x, x is 0. So 2 times 0 plus 3y equals 21. Okay. 2 times 0 is 0. So we end up with 3y equals 21. Divide by 3, y is 7. So our solution is 0, 7. Does anybody want any more of these? Anybody? Really very easy. They just look hard for some reason. But you can see that the process is really much simpler than the other one. Okay, I sent you a sheet on math formulas. This is one of the ones that's on there, I'm pretty sure. It's about exponents. And when you look at the explanation on the math sheet, it's like, what the hell is this boy talking about? This doesn't make any sense. Right. If we have 4 squared, what does this mean? For one thing, you never, I know never is a long time, but never multiply these two numbers. What this means is, how many times do you multiply? This is called the base number. How many times do you multiply the base number times itself? As my ex-wife would say, its own self. So this is 4 times 4. Last is 16. Right. Now, everybody okay with that? Okay, hopefully this is not the first time you've seen this. Now, what happens if we have a squared times a to the cubed? What we do here, if you have the same base numbers, and we do, if you have the same base numbers, what do you do with the with the exponents? You add them. Okay? Same base numbers, and you're multiplying, you add the exponents. Because what does this mean? This means a times a, right? This means a times a times a. Now, the exponents on these are 1. We just don't write them. 1, 2, 3, 4, 5. So this equals a to the. Okay? When you have the same base numbers, the base numbers are on the bottom. have the same base numbers, and you're multiplying, you add the exponents. And let's see. Mm-hmm. Mm-hmm. Now, this is called the product rule. That's not particularly important. But the power rule, is everybody okay with this? Like if we had a to the 5th power times c cubed, what does this mean? A to the 5th c cubed. Can't do anything because the bases are different. Now the power rule is if you have a power raised to a power, like if you have cubed squared, okay, if a power raised to a power, this is, now the formula that I gave you will say this, a to the 3 times 2, which is a to the 6th. So what is our rule here? If you have a power raised to a power, multiply the exponents. Okay, so if you have b squared raised to the 5th power, this is b to the n. Right. This, we have, let me show you this again. A cubed all squared, what does this equal? Remember, this is the base number right here. And how many times are you multiplying it times itself? Twice. You have a cubed times a cubed, which is, now what do we do? We have the product rule. The product rule says that you have the same base numbers, you add the exponents, so that's a to the 6th. The rule here is if you have a power raised to a power, you multiply these two numbers, a to the 6th. Right? Right. Mm-hmm. Mm-hmm. Now, if you're adding or subtracting, excuse me. But wait, let me back up a little bit. If you have c to the 5th times d to the 4th times c squared, do we have like base numbers? Yes, here and here. Okay, so we can, these two are the same. So what does our product rule say? Our product rule says you have the same base numbers, add them, c to the 7th, d to the 4th. I'm not going to be real wild about this, but you are going to find somebody later on down the road in college algebra or calculus or something like that will make a big deal out of this. It's the largest exponent first. The exponents are the same. Alphabetical order. So here we have the largest exponent, 7. So this is our answer here. There's nothing you can do with the d to the 4th power. Nothing that you can do, so it just stays the same. Now, adding and subtracting. If you have 8 x cubes, it's 5 x cubes. In order to be able to add these two terms, in order to be able to add those, you must have the same exponent and the same base number. Okay? The exponent has to be the same. They are. The base numbers have to be the same. You have 8 x cubes. You have 5 x cubes. Everything is the same except the coefficients, the numbers in front of the letters. So you can do that. Now, what about this if you're so smart? 5a cubed plus 7a to the 5th. Are these like terms? No. Have the same base numbers, but the exponents are different. This is okay. The way we would write this answer is largest exponent first, 7a to the 5th plus 5a cubed. I'm not going to be real wild about this. I really don't care. But on the final exam, they are going to be like this: largest exponent first. And again, if they have the same exponent, alphabetical order. So if we have this, we have come on, boy, think 6b cubed plus 8a to the 5th. Are these like terms? No. Largest exponent. Stupid. Meant to do this. 8a cubed. Exponents are the same, but the base numbers are not the same. So what do we do here? 8a cubed plus 6b cubed. Largest exponent first. If the exponents are the same, alphabetical order. Right? Right. Okay. Not super whiz bang important, but you are going to see this from time to time. Now, what if we have this? We have 3 over 4 all squared. This is kind of like the distributive property for exponents. You have to distribute the 2 over everything inside here. Because remember, this is the power rule. The exponents here are 1s. This is going to be 3 squared, 2 times 1, 2, over 4 times 2. This is 9 over 16. And I don't think you can reduce that. Okay? Remember, the parenthesis makes this one number. This is actually 3 over 4 times 3 over 4. Okay? Again, the parenthesis makes this one number. You're squaring the whole thing. And what about this? You have c over 3 all squared. Now again, we're going to distribute the 2 over everything inside the parenthesis. This is going to be c squared over 3 squared. This is c over, what is that, 9? Okay. Okay. Take a drink of your Diet Coke. C cubed over e to the 5th all squared. Remember, the power rule says multiply. You have a power raised to a power, you multiply. This is going to be d to the 6th over e to the 10th. Okay? Okay. Okay, I'm sorry. What would be good right now? Snickers. Oh, man. Okay, the power rule is if you have a power raised to a power, multiply the exponents. Okay, what if we have this? What if we have 3a squared b cubed all raised to the say to the 2nd power. Remember, 3 there is a term in here also as an exponent of 1. So that's going to be 3 squared a to the, remember when you have a power raised to a power, we multiply to the 4th, b to the 6th, so this equals 9, a to the 4th, b to the 6th. Okay? 3 squared is 9, a to the 4th, b to the 6th. Don't forget, when you have these, and this is going to be on the final exam probably. Like I said, I'll get a copy of the final before you have to take it, and we'll go over it. In all the finals before, they have had this. Okay, what about this? 5a squared b to the 5th over c to the 6th, all in parentheses, squared. Remember, everything in here you have to raise to the 2nd power. If you have a power raised to a power, you multiply. This is going to be equal to 5 squared, because remember the exponent of, exponent on the 5 is 1. A to the 4th, okay, 2 times 2, b to the over c to the 12th. All right? 2, 4, and, oh, yeah. Okay? Now, we'll just go over this kind of briefly, and then we'll quit. Now, remember, when you had a squared times a to the 5th, what did we do here? Added. Right? When you multiply and you have the same base numbers, you add the exponent, so that would be a to the 7th. Now, you're so smart, get this. What if you have b to the n, isn't going to make a lot of sense, over b to the c. Remember, when we multiplied with the same base numbers, we added the exponents. Here, we subtract them. This one minus this one. Because if you have x to the fifth over x cubed, what is x to the fifth? Now what we're going to do here is this is going to end up being x squared. Hope. And what does x to the fifth mean? 1, 2, 3, 4, 5. Over, okay, x times x times x times 5 of them. Remember, they all have exponents of 1. What would we do here? We would add the exponents, the x to the fifth. Here, x to the third is x times x. What's any number times itself? 1. Same thing here, 1 and 1. What are we left with? X squared, the numerator. And what happens if they're in the denominator? If you have a cubed over a to the sixth. This is a times a times a over 1, 2, 3, 4, 5, 6. Any number divided by itself is 1. Now what's in the numerator here? Remember, all these are 1, so it's going to be 1 over a cubed. 1, 2, 3. But remember, our formula says subtract the exponents when you're dividing. When you multiply, you add the exponents. When you divide, you subtract. This is actually x to the 5 minus 3, which is squared. Okay, now the instructions that you're going to get will say evaluate with all positive with all positive exponents. Okay, this is real simple. If the exponent is negative, move it. If it's in the top, put it in the bottom. If it's in the bottom, move it to the top. So if you have this, if you have m to the minus third over r to the minus 5. Look, I'll tell you the simplest way of doing this because it's kind of confusing. Is draw the fraction bar. Take these one at a time. You don't really get any more difficult than this. You just get longer. So take them one at a time. M, the minus third, where does it go? The bottom. And when it does, when you move it, the exponent becomes positive. R to the minus 5, the exponent is negative, so you move it. And the exponent becomes positive. Okay? W to the fifth over W to the minus third. Again, solve the fraction bar first, Take them one at a time. W to the fifth, where does it go? Stays on the top because the exponent's already positive. W to the fifth. W. The older I get, the worse my handwriting gets. And W to the minus third, where does it go? It goes to the top because the exponent's negative. Over 1. Now we have the same base numbers. We're multiplying here. So this is W to the 8th. You can write the over 1 if you want to. How about if we don't have a quiz this time because of the holidays? Say it. Say it. Well, Johnny, you're such a good boy. Mm-hmm. And pretty stupid. Okay. Mm-hmm. Mm-hmm. Okay. This is what you're going to see. Like I said, they really don't get any more difficult. They just get longer. All the fraction bar. Take these one at a time. E to the minus 3, where does it go? To the bottom, because the exponent is negative. So it's going to be a cubed. E to the 4th stays, right? Because the exponent is positive. E to the minus 5. Oh, stupid boy. I'm sorry. There you go again. This equals fraction bar a cubed. E to the 4th. Okay. C to the minus 5 goes to the bottom. C to the 5th. Did I get it right that time? E to the minus 2, the exponent's negative. So move it. E squared and E cubed is already positive, so it stays where it is. Now, do we have any like terms? B's, no. D's, no. A's, no. C, E, no. Okay. I had enough. Good stuff, huh? Okay. Unless I get real ambitious, I don't think we're not going to have a quiz this time. But you want one? Cotron wants one, don't you, Mr. Cotron? See it. 5. Toy Moon. He's out smoking a joint, I bet. Mm-hmm. Okay. All right. Y'all have a happy Thanksgiving. Don't worry about me and Mr. Razzo, Mr. Razzo and I, we're going to have peanut butter and jelly, don't worry about us. Hey, Razzo. He's out smoking too.
Oh no.
Okay. Y'all have a good Thanksgiving. I'll see you next week sometime. Bye. Bye, Bonds.
All right, everyone.
Thank you. You too.
Bye. Have a good day.
Bye-bye.
Bye. Have a good one.
Bye-bye, Coach Cotron.